Okay. What would be the units for your rate constant? Okay, remember this K right here in the expression, that's called your rate constant. What would be the unit for that? Well, it depends on the overall order of the reaction, okay? And the overall order, N, is just the sum of the orders. So this is second order with respect to X, first order with respect to B. So the overall order is 1 plus 3, or 3, okay? So what would be the unit for K? Well, let's look at this particular example, okay? Might be better to, let me try a different approach here. So let's rearrange this equation to solve for K. What would you do to solve for K here? Let's rearrange this one. K would be equal to rate divided by 1. Concentration of X squared times concentration of Y raised to the power 1, right? So what would be the unit for your numerator? Moles per liter per second, right? A concentration unit divided by a time unit. What would be the unit for your denominator? This is moles per liter squared, and then that's moles per liter, right? So this is just moles raised to the power n, right? Moles cubed, moles per liter cubed. So the unit for K is moles, okay, this one, molarity over molarity cubed, molarity raised to the power 1 minus 3, times reciprocal time. So in general, your concentration, your unit for your rate constant is a concentration unit raised to the power 1 minus n, where n is the overall order times the reciprocal of a time unit. So what happens if n is 0? If n is 0, then you say rate equals K. Okay, there's no concentration units here because it's raised to the power 0, right? So K will have the same unit as rate, so it's concentration per unit time. So moles per liter per second, for example, or moles per liter per minute. Okay, that would be the unit for your rate constant. What happens if n equals 1? Then if n is 1, concentration unit raised to the power 1 minus 1 times time to the negative 1. What is concentration? What is 1 minus 1? So concentration raised to the power 0 will just disappear. So unit for your rate constant is per unit time. In other words, if I were to give you a rate constant, by just looking at the unit, you should be able to tell me what the overall order of the reaction is. Is it 0 order, first order, or second order? If it's second order, then concentration raised to the power 1 minus 2 times time raised to the negative 1 would give me concentration to the negative 1 per unit time. So what would be an example of a second order rate constant unit? So it could be molarity, reciprocal molarity per unit time, right? So I can write it that way. Or I can say moles per liter to the negative 1 per second. Okay, so this is second order rate constant. Or I can say per mole times liter per second. Okay? So per mole times liter per second, or you can say liters per mole per second. That would be a unit for a second order rate constant. So let's look at this one. What is the overall order of reaction if the rate constant is 2.5 times 10 to the negative 3 per second? You're given the unit for the rate constant. Ready? First order. Okay. You go back and see. If it's just per unit time, it's first order. Okay. If it's concentration per unit time, it's 0 order, just like rate. If it's per concentration per unit time, the overall order is second order. Okay, how about this one? What's the overall order if the rate constant is 0.25 liters per mole per minute. Okay. Second order, very good. Okay, because liters per mole is moles per liter, right? Reciprocal of moles per liter. So this is concentration, reciprocal concentration unit times a reciprocal time unit, second order. Very good. How about this one? What's the overall order of the reaction if the rate constant is 2.0 times 10 to the negative 4 per molarity per second? Second order. Okay? Per molarity means concentration unit to the negative 1, right? Times a reciprocal time unit. How about this one? What's the overall order if the rate constant is 2.0 times 10 to the negative 4 moles per liter per hour? Correct answer? Zero order. Very good. Concentration unit times the reciprocal time unit.